Okay, this is MGF 1106, Chapter 2, Section 3. This is Part 1 of this section because there's a lot of information in here. This is Venn diagrams. Venn diagrams are used basically to represent complements, intersections, and unions within multiple sets from a universal set. So the complement in set theory, if the complement of a set A is symbolized by this A prime, and that's the prime symbol there. It is the set of all elements in the universal set that are not in set A. So in a Venn diagram, we draw a square to represent the universal set. Universal set, remember from section 1, is the set of elements that are all in this particular universal set. So set A would be symbolized by this blue circle. Any element that's not in set A would be the complement. So for instance, if we had numbers 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 would be the universal set. Say set A was 2 and 3. That means the complement would be 1, 4, and 5. So the complement is what is not in the set. Example. And this is example 1 in the textbook. It says given the universal set is A, B, C, D, E, F, G. Set A is just A, C, E. That means if we take A out, and we take C out, and we take E out, then B, D, F, G is the complement of A. And we write that in a Venn diagram form. There's a square representing a universal set. Here's our set, A, C, E. Here are the elements that aren't in set A, which are the complement of A prime. Notice that the universal set has all the elements in here. Okay, so the square represents all the elements. It's the universal set. Set A is ACE. A prime, which is the complement of A, is BDFG. We come over here and start talking about intersection. The intersection of two sets, symbolized by an upside down U, is the set containing all elements that are common to both sets A and B. Example 2, the universal set is all 50 states of the U.S. Set A is California, Texas, Florida, New York, Pennsylvania, Illinois, Ohio, Georgia, North Carolina. Set B is California, Texas, New York, Illinois, Pennsylvania, Arizona. If we draw our Venn diagram, again, here's our square with our universal set, which would contain all of these. In set A, which is the blue, you've got Ohio, Florida, Georgia, and North Carolina, which is only in set A. For set B, you got Arizona, which is only in set B, but California, Texas, New York, Illinois, and Pennsylvania are the intersection of set A and set B because they're in both sets. Notice that the blue circle contains all of these states. Notice the red circle contains all of these states. So this intersection is where set A and set B have common elements. California, Texas, New York, Illinois, Pennsylvania. That's what's in here. We then come to union. And the union of set A and B, symbolized by a U, is the set containing all the elements that are members of set A or B, or in both sets. So here's example 5. Your universal set is the numbers 1 through 10. Set A is 1, 2, 4, 6. Set B is 1, 3, 6, 7, 9. Set C is an empty set. There's no elements in it. It's a null set. Letter A says, find the union of A and B. Well, it would be 1, because it's in both sets. It would be 2. It would be 3. It would be 4. It would be 6. That's in both sets. 7, 9. Union is all the elements that are in both sets. You just don't write or repeat an element. So see, we only wrote 1 once, even though it's in both sets. We only wrote 6 once, because it's in both sets. Letter B says A union C. Well, if we look at A here, if we look at C, C is an empty set. So the only union between A and C is set A, because there's no elements in C. Set C says A prime union B. All right, so here's A, 1, 2, 4, 6. That means A prime is 3, 5, 7, 8, 9, 10. If we look at B, we have 1, 3, 6, 7, 9. So the union of this is 1, 3, then 5, 7, or 6, 7, 8, 9, 10. When we come to letter D, notice the parentheses are around the whole thing. So we're looking at the complement of A union B. Well, here's A union B here. Okay. So if we look at the complement of A union B, we're looking for all the elements that are not in the union of A union B. So 1 is in there, 2 is in there, 3, 4, 5 is not. So 5 would go as a complement. 6 is in there, 7 is in there, 8 is not, so 8 would be a complement. 9 is in there, 10 is not. So the complement of A union B, which is this, would be the elements that aren't in this union A union B, which is 5, 8, 10.